Combustible dust explosions are a serious risk at many manufacturing and processing plants. And an unprotected dust collection system can be a main cause of an accident. An explosion in an unprotected dust collector produces a high-pressure wave that can fragment the housing and send heat flames and dangerous projectiles into the workplace. This can critically injure personnel and damage equipment and buildings. So make sure your dust collector has an effective explosion protection system. The goal of any type of explosion protection equipment is to control an explosion, keep employees safe, and minimize damage. There are two main types of protective systems you can use: active and passive. Active systems, such as chemical isolation and fast-acting valves, react prior to or during a deflagration event. Passive systems react immediately following an event to prevent the deflagration from traveling to other areas and causing more damage. Most manufacturers use passive systems because they are a lot less costly and require less frequent inspection and service. All passive systems control the speed of explosions by releasing the pressure produced when they have reached a certain limit. Passive systems include explosion venting, flameless venting, explosion isolation, and safety monitoring filters. Explosion venting is the most commonly used passive system. It's designed to safely vent the gases and pressures from a deflagration to minimize damage and injury to workers in the area. ATEX and NFPA standards and guidelines set the criteria for the design, location, installation, maintenance, and use of these systems. Here's how it works. The dust inside the collector combusts, which increases the pressure inside. The explosion vent releases when the pressure reaches an unsafe level. The vent opens, allowing pressure and flame front to exit to a safe area. Flameless vents can be installed over a standard explosion vent to extinguish the flame front as it exits. This enables the venting to be installed indoors. An isolation valve provides an additional layer of protection. These valves are installed in the inlet ducting to create a mechanical barrier that keeps explosion flame and pressure from traveling through ducts into the process area. Normal airflow keeps the flap plate open. But if an explosion occurs, the pressure wave forces the flap closed and flames and smoke are contained. An integrated safety monitoring filter, or ISMF, can be used as an outlet protection device because it protects the downstream equipment and work areas. Installed on the top of the dust collector, the integrated safety monitoring filter acts as a flame front barrier. In the event of a dust collector explosion, the filter also prevents the flame front from entering the workspace because it contains the explosive dust in the collector. The ISMF has been evaluated in multiple full-scale tests for its flame-stopping properties, using organic ST2 dusts as well as ST1 metal dusts. Specifying the correct ATEX or NFPA-compliant explosion protection technology for your dust collector will minimize personnel injury, equipment damage, and prevent the structural failure of your facility. For more information, call your local Camfil office or visit camfil.com/APC.